ដូចជា referent នៅថ្ងៃ
One of the four basic welding positions encountered in practice is the horizontal position. So in this film, we shall concern ourselves with shielded metal arc welding in the horizontal position, demonstrating with fillet and groove welds. A fillet weld in this position is considered horizontal. The limits of this position are 15 degrees in this direction, 15 degrees in this direction, 10 degrees in this direction, and 15 degrees in this direction. Since the horizontal position is one of the more difficult positions of welding, it is especially important that we remember the four main factors. These are 1, current setting, 2, angle of electrode, 3, length of arc, and 4, speed of travel. Both size of electrode and thickness of plate must be considered in making the proper current setting. We are using a 3/16 all-position electrode, AWS class E6010, with direct current reverse polarity. The current setting with normal arc voltage should be in about this range. With the joint to be welded placed in this position, the operator strikes the arc and must immediately build up the weld to the required size. The maximum size of a good single-pass fillet weld in the horizontal position is approximately 5/16 of an inch. Control of the molten pool is largely a matter of proper manipulation of the electrode. The electrode is moved forward slightly to melt the base metal. Gravity causes the molten metal to flow toward the bottom plate, producing an undercut area in the vertical plate, which is then filled by moving the electrode back again. This cycle is repeated as the weld progresses. The covering on the electrode forms a gas that protects the weld metal from the atmosphere. It also furnishes fluxing and slagging ingredients that serve to clean and protect the weld. The weld will have good shape. Practically no metal will be wasted. It will join the plates with good fusion, with minimum undercut and overlap at the edges. The weld is started with the electrode held at about this angle. During the first few inches of travel, the electrode is brought up to a steeper angle, and this is maintained until the last few inches of the joint are reached, when the electrode is tilted back at about this angle. This is done to overcome the effect of arc blow. In order to properly control the pool of molten metal, it is important that we hold the correct arc length. If the arc is too long, the metal is hard to control and there is excessive spatter. The weld is irregular, with most of the weld metal on the bottom plate. There is excessive undercutting on the vertical plate. If the arc is too short, it is hard to maintain a continuous molten pool, and slag and gases are likely to be trapped. The weld is irregular, with slag inclusions. Fusion is poor, especially at the root. If the current setting on the machine is not correct, we will encounter difficulties. If the current is too high, there is too much heat, causing the metal to melt too fast for good control. Slag is hard to remove, and spatter is excessive. There is undercut at the top, and penetration is too deep. There is a serious waste of metal. When the current is too low, there will not be enough heat to melt the base metal properly. It will be difficult to hold an arc. The weld is irregular. with slag inclusions. Fusion is especially poor at the root. Note slag and gas inclusions. The correct speed of travel must be maintained. If travel is too fast, the heat does not have time enough to melt the base metal properly and to maintain a proper molten pool. The weld will be undersized. The vertical plate is undercut. There is poor fusion at the root. When the speed of travel is too slow, there is too much base metal melted. The weld is irregular, with excess metal on the lower plate. The vertical plate is undercut. There is overlapping on the bottom plate. Weld metal is wasted.